Woo-hoo! This is now my third attempt at recording this video. I'm about to scream. It keeps freezing up on me, but let's go for it, shall we? I love doing things 3 times in a row. Alrighty. So, new chapter. The inverse, sine, cosine, and tangent functions are what we're starting with. Call back to 5.2 when we first talked about inverse functions, right? So if a function is one-to-one, it has an inverse, right? However, not all functions are one-to-one, but we can restrict the domain to make it one-to-one. So we're going to have to do that with our trig functions, because trig functions are functions, but not necessarily one-to-one, right? So if we take a look at this one here, yeah, it passes the vertical line test. So it's a function, but not the horizontal line test, right? But let's talk about our domain and range of our sine function, shall we? Alrighty. So my domain is from negative infinity to infinity. My range is from -1 to 1. Cool. Awesome sauce. Well, how can I make this pass the horizontal line test? Well, I can take a section of it. I'm going to go from -π/2 to +π/2. In this section, it passes my horizontal line test, meaning it only intersects at once, right? If I were to go past it or pass it in the other direction, I wouldn't pass the horizontal line test. So that's where I'm going to restrict it. Now, what does that look like on this inverse relation that we have here, right? It's not a function yet, but if we restrict, it'll look like this. There we go. Awesome. Wonderful. And if I take this here, oh my goodness, get ready for tech marvel. Whoop! I'll pop it over on this last one, and then we'll talk about it as an inverse. But first, I'm going to go ahead and put my range and domain and range here. So my domain of this relation, my x-axis, it's restricted from -1 to 1, and my range, because they switch, is from -infinity to infinity. But once I restrict this, right, if I were to restrict my domain of the sine function to -π/2 to π/2, that's what my range would now be, -π/2 to π/2. My domain, since my range wasn't an issue before, in the original, my domain is now -1 to 1, and that's no big deal. That's a weird bracket. And I'm going to go ahead and label the graph axes. Boom. There we go. I like it. Awesome. Fantastic. Wonderful. So we have to restrict our domain of the original function in order for its inverse to also be a function, is what we're getting at there. Okay? Awesome. Wonderful. Fantastic. How many times have I said awesome already? It's going to happen a lot. So here we go, our little formal definition there of the inverse sine function. I also like that yellow box there, where it shows what we're restricting x to, as well as y, our outputs, right, of that inverse function. Okay, so finding the exact value of an inverse sine function. The way this reads is inverse sine of 1, or we can think of it as sine of what angle, theta, is equal to 1. So where would sine equal 1? Well, that would be at our first quadrantal, right? At π/2. So my solution to this is π/2, or 90 degrees, right? Depending the units that you're asked to use, or your choice. Okay. Not too bad for the first one. Next one. Inverse sine of -1/2. So that would mean sine of what angle is equal to -1/2? Well, I know that -1/2, whether you think of it with unit circle or special right triangles, if I draw it up on my XY coordinate plane, I could have -1/2 either here, -1, hypotenuse of 2, that's a √3. This is a pi, or a 30-degree reference. I'm going to go with degrees right now. And this could also be negative over here, with -1, 2, and then -√3, and still a 30-degree reference. Okay. Well, didn't we say that we had to restrict the domain of our original function to be between -π/2 and π/2? Well, if I think about my unit circle, that's a -π/2 rotation. This is a π/2 rotation. So my solutions have to come within these the first quadrant and the fourth quadrant, right? So my answer for this one would be a -30-degree rotation, or -π/6. Okay, that would be my solution for that one. I couldn't do 11 pi over 6. I can't do 7 pi over 6. That's not going to work. Okay. It has to be between negative pi over 2 and pi over 2. So I have to choose my solution carefully. Okay. I don't know why I switched to blue from purple. That's a little weird. Whatever. All right. Next one. Inverse sine of 3 over 2. So again, we can think of it as sine of what angle gives me 3 over 2. If I do remember correctly from honors geometry and my SOHCAHTOA, opposite over hypotenuse, that's what sine is, right? When is the opposite side ever larger than my hypotenuse? Never in a right triangle, pretty sure. So this is undefined. It cannot happen. Lovely, lovely, fantastic, and wonderful. So big thing I want you guys to jot down here is that when I'm talking about my solutions for inverse sine, so inverse sine of theta, it's going to be positive up here, and inverse sine of theta, it's going to be negative down here. So your solutions are always going to come between pi over 2, or sorry, negative pi over 2 and pi over 2. Okay? Whether you're looking at your unit circle, you're looking at quadrants 1 and 4, but remember it's going to be a negative angle of rotation there because we restricted the domain of the original function. Or if you're thinking special right triangles, you'll position them in quadrants 1 and 4. Although they exist in others, they're not within the domain restrictions of our original sine, which is now a range restriction, an output restriction of our inverse function. Whew, that's a lot. Okay, let's keep cruising here. Approximate the values of the inverse sine functions using your calculator. Okay, so let me pop these up here. What's nice is these are basically just as is in your calculator. Let me clear this out. I would hit second inverse sine, right? And then 1/3. Now, if you don't get the solution that I have up here, it does say in radians, that's 0.339, so 0.34. If you did not get that, hit mode. Make sure you are in radian mode. All right. Lovely. So 0.34 was my rough radian measure. And if I plug in for this one as well, you want to try that on your own. Second sine, and then negative 0.25 or negative 1/4. My calculator value, my calculator equivalent will be, or sorry, my radians will be negative 0.25 rounded. Alrighty. Last thing about, or actually a couple last things about sine here. Sorry if I'm moving a little fast. I feel like I've taught this 3 times. Oh, wait, this is the 3rd time because it keeps freezing up on me. So hopefully not this time. Fingers crossed. In terms of the sine function and its inverse, just like in 5.2, we were talking about like compositions of functions. The composition of the function and its inverse are going to equal x, and that's what you see here. Big things to remember are my restrictions here and here, okay? So let's take a look at this first one, shall we? Inverse sine of pi over 8, right? So inverse, it looks like they just cancel each other out. You're left with pi over 8. Well, as long as, let's see here, sine of pi over 8, we're dealing with the first one up top here. Does pi over 8 fall within negative pi over 2 and pi over 2? It sure does. So my solution is just going to be pi over 8. However, on this second one, 5 pi over 8 falls outside, right? If we were looking at our angle of rotation here, I'd be looking at something like this. I'm just past pi over 2, right? 4 pi over 8 is pi over 2. So I'm just past that. So this is 5 pi over 8. And my reference angle is 3 pi over 8, because that would rotate a full pi, right? Well, sine, I know, is positive in that second quadrant, and it's also positive in the first quadrant. So since I know the reference is 3 pi over 8, I would get an equivalent answer in the first quadrant with 3 pi over 8, right? So really, 3 pi over 8 would give me the same thing, sine of 5 pi over 8 and sine of 3 pi over 8. They give me the same answer, okay? So since 3 pi over 8 is between negative pi over 2 and pi over 2, I can use that, and boom, 3 pi over 8 would be my answer here, right? So I can still think of it as like almost the signs canceling, but I got to be careful with that angle that's in there to make sure that it's within those restrictions. And I'm going to show you guys this with the calculator. I'm going to type it in real quick. All right, so here we have in the calculator the initial problem that we had, which gave me a decimal of 1.178. and so on and so forth. I also did it with 3 pi over 8, which we knew was our reference angle. And since in the second quadrant, sine is positive, I'd get the same value in the first quadrant where sine is also positive. So 3 pi over 8 should all be equivalent, right? And then I showed 5 pi over 8. So if we were to think of it as like, oh, they just cancel out and I get 5 pi over 8, that's not equivalent to what you see there. But 3 pi over 8 gives me the 1.178, so on and so forth, that I had for all the others. So your calculator actually takes into account where your inverse function is defined. It knows that it's a smart little machine there. So just a little kind of sort of proof on the calculator. If you're not taking my word for it, take the TI-84 Plus Silver Edition word for it. Okay? Awesome. Wonderful. Fantastic. Let's keep going. On to inverse cosine, and something I forgot to mention before. Sometimes you'll see arc cosine or arc sine or arc cos, arc sine, right? Those just mean inverse sine or inverse cosine. So it's another notation. No big deal. All right. So for my first one, it's following the same way we did with sine, except for where I'm restricting. Remember, we had to pass that horizontal line test. So I'm going to actually restrict from 0 to pi for my cosine function. The domain and range are the same, and then they flip-flop for the inverse. But I'm going from 0 to pi. That will pass my horizontal line test. And as you can see in the inverse, when I highlight that same section, it passes the vertical. Now, if I take my fancy-dancy Control-C, Control-V, little copy-paste, still remember the day when I remembered that shortcut, learned that, and you're like, oh my God, I'm awesome. Control-C, Control-V, you know, right on. All righty, cool. So I pop that over. I don't want that to be purple. I want that to stay. I didn't even know this thing would do that. My goodness. What the heck? Okay, there we go. Let me take the pen. And now, no. There we go. Okay, I got to unhighlight that. Alrighty. Here we go. So my units are going to be 1, -1, pi over 2, and then pi. It's kind of a terrible pi there. That's better. Alrighty. So what's my domain and my range here? Now my restricted one. So I restricted my domain of the original to 0 to pi. So that is now my range 0 to pi. And then my range and the original was -1 to 1. I didn't really restrict that. It's just going to stay -1 to 1 in my inverse, right? Because they flip flop. Okay. Domain is restricted in the original cosine function, which then correlates to my range of the inverse, so from 0 to pi. And we have the same thing that we had for the sine written down here in a nice little type and in our yellow box. Let's go ahead and use it. So inverse cosine of 0, or in other words, we can think of it as cosine of what angle is going to give me 0. All right. Well, what angle will give me 0? That is my first quadrantal once again, right? That's a 0x coordinate on my unit circle. So that would be pi over 2, or 90 degrees. Next one, inverse cosine of -√2 over 2. I know the root 2 over 2s are my 45 degree or pi over 4 reference angles, right? But where is it negative? I just said that our domain of the original function, if we want to think of this as cosine of what angle equals -√2 over 2, I just said my domain of the original is limited from 0 to pi. So we're only dealing with this portion of my unit circle, okay? Only deal with quadrants 1 and 2. Well, where is that going to be negative? Well, if I position that, is my 45. This is pi over 4 here. This would have to be 3 pi over 4 for my solution. And 3 pi over 4 is between 0 and pi. Awesome. I like it. Fantastic. Cool. And you could also even think about this as, since you know it's like a 45 reference or a 45, 45, 90. If you're a special right triangle type of person, you're like, okay, well, I can draw my 45 degree reference, and it's gonna be -1, 1, and √2. It's a little weird with the rationalized √2 over 2, right? Not as easy to see, but you can see that, okay, well, then this rotation right here is going to be 3 pi over 4. Okay? Fantastic, wonderful, awesome. Big thing we want to write down is that our solutions are coming from the first and second quadrant. We're going to write that all down together at the end, but if you do want to, notating that cosine is going to come from 0 to pi, and we're talking about our solutions only in this area all the better. Go for it. Cool. All righty. It all says our inverse, right? The properties, the inverse properties. So f inverse of f of x is equal to inverse cosine, inverse cosine of cosine of x, which equals x, right? They appear to cancel each other out, just like we were talking with the sine. But remember, we got to pay attention to those restrictions on our x value. For the first one, it's from 0 to pi, right? We're restricting the domain of the original to be between 0 and pi. And then for the other one, it's going to be from -1 to 1, which was our original range of the function. Coolio. So if our first one here falls into the top category, so it needs to be between 0 and pi over 12 is between that. So it's just a simple bing, bang, boom, pi over 12 is my answer. Okay. Because what I'm going to have is I'm going to have some angle of rotation like this, right? It's in the first quadrant. I can evaluate inverse cosine in that first quadrant. It exists there, right? So it's just pi over 2. That's the angle that's occurring. Here's where it gets cray. So negative 2 pi over 3 definitely does not fall within the 0 to pi range, right? But let's go ahead and evaluate what's cosine of negative 2 pi over 3. Well, that would be down here. This is negative 2 pi over 3, which has a reference of pi over 3, right? It would be pi over 3 to get to that x-axis. And if I'm looking at my unit circle or I'm using special right triangles, right, this is a 60-degree reference. You can think of it in our special right triangles world right here. This would be negative root 3. This would be a -1 and a 2. And cosine would be adjacent over hypotenuse, so that would be -1/2. Okay, so that would be for the inside here. I can also see that on my unit circle, which I've copied and pasted over here for ease, we were looking at this guy right here, and my x value is my cosine, which is -1/2. Okay, so I know that cosine of negative 2 pi over 3 is -1/2. So now we can think of it as cosine inverse of -1/2. And I believe we did one just like that, if not exactly that. Let me look at my other notes that I have over here. We didn't do exactly that, but we can do it, right? So for what angle is cosine going to be -1/2? Within the restrictions, right? From 0 to pi. Where is cosine going to equal -1/2? Well, it's going to be negative in my second quadrant. And if I'm going special right triangles, I'm thinking of a triangle right here, where I'm going to have -1, root 3, and 2. So this is going to be a 2 pi over 3 rotation here. And I can also see that here on my unit circle with the x value being -1/2, which I kind of covered up. There we go. Awesome. So 2 pi over 3 would be my answer. It's kind of working like some people refer to it as an onion. Inside out. It's in layers, right? Layers like an onion. Feel free to think about that. I don't care. But I evaluated the inside, and I knew that it wasn't just a cancel it out because that -2 pi over 3 was outside of those restrictions. So I had to evaluate it a little bit more intensely by hand. Let's keep going. All right, cosine, or inverse cosine of pi. Well, hold the phone here. That would be our second scenario, and x has to be between -1 and 1. Is pi between -1 and 1? This is undefined. Coolio. All right. Wonderful. Fantastic. Awesome. Cool. Next one. And also, by the way, if you want to think of it as like, for what angle will cosine equal pi? It's never going to be that. Okay. For what angle does cosine, equal pi? It's not going to be that. Cosine will equal 1. It'll equal -1, right? It'll equal -1 at pi, which is where it gets kind of confusing because you're like, wait a sec, it could do that. No, it's going to equal -1 with an angle of pi, not the other way around. Okay. Easy to mess that one up. Sometimes I think about it like a bunch of times too. Okay. Last one here. We have cosine of inverse cosine of -0.4 or -2/5. That is definitely between -1 and 1. So nice and easy, -0.4 or -2/5. However you want to write it is up to you. Awesome sauce. Whoo! One last one. we're cruising our way into tangent, and I popped on some wonderful, wonderful asymptotes here for our tangent function. I'm psyched about it. I'm pumped, and I'm really hoping that this video uploads this time. I'm honestly terrified because, again, this is the third attempt at this, and I feel like a broken record at this point. All right, let's go. So my domain of a tangent function is going to be x such that x cannot equal pi over 2 times k, where k is an odd integer. You may also see it written as x cannot equal pi over 2 plus pi k, where k is an integer. I know our online book writes it like I have here. So my range, if I'm going to stick with the same notation, y such that y equals all real numbers, right? Or negative infinity to positive infinity, but it's always fun to do that double stick R. Feels very, very mathematically powerful, right? Okay. So there we go. In our inverse relation, the domain and range are going to switch, but let's pop on over to the real important one, which will be our restricted, inverse function, right? My domain is going to be x such that x equals all real numbers, right? It's going all the way to the left, all the way to the right. Cool. Or I could go, since it's not really going to be canceling anything out, I think that's cool. Yeah, that's fine. You know what? I'm going to go negative infinity to infinity on this one, because I feel like using interval notation on the next one rather than set builder notation. So for my range, I'm going to be between negative pi over 2 and pi over 2, but hold the phone. Those are asymptotes. So I'm going to use parentheses rather than brackets like all the other ones, right? Awesome. Fantastic. Got our domain and range. Once again, we have our notation down there. Feel free to jot any of that down you'd like before we go ahead and use it. We're going to do a little bit of evaluating here with tangent. I can't wait. I'm so psyched. Let's just, you know what? I don't know if I can wait any longer. Let's go for it. But just like one last thing, actually, just like sine, if you look at this right here, we are going to be dealing with, if we want the inverse of tangent, it's going to be positive up here. It's going to be negative down in the fourth quadrant. So quadrants 1 and 4, we're thinking of it between negative pi over 2 and pi over 2. That's where our solutions are going to come from. Let's cruise. Okay. So we want to evaluate here. We want to solve for y, right? We got tangent or inverse tangent of 1. Okay, so where is, again, I feel like it's nice to think about it this way for a lot of you. For what angle will tangent equal 1? Ooh, that's at my, like, where it's root 2 over 2 and root 2 over 2 for my coordinates, right? That's a pi over 4 reference. It's positive first quadrant, pi over 4. Had that been a negative one, negative pi over 4 would be my solution. All right, next one. Negative root 3. Now, here's where I really prefer special right triangles. If I were to draw this up, I know it's negative, right? And I know that tangent is going to be negative in my fourth quadrant here. And tangent is opposite over adjacent. So negative root 3 here and 1, because I can think of this as over 1. And that would make this a 2 here. It's a 30, 60, 90 triangle. Now, since the root 3 is my larger side there, that's going to be a 60-degree reference or a pi over 3. So this would be negative pi over 3 to be within my domain restrictions. Okay, otherwise you're looking at the unit circle and you're trying to find what multiplying by the reciprocal is going to give you that negative root 3, and I feel like it can be kind of cumbersome. So I really prefer the special right triangles on that one and positioning it accordingly. Lovely, fantastic, wonderful. I like it. Alrighty. Same inverse properties here for tangent. We've done enough of those examples, so feel free to jot that down. And then what we're going to do is we're going to have nice one location where we're going to talk about where everything's positive and negative. Okay? So let's do that now. Again, feel free to pause if needed. All right, for this one, I know that sine inverse of theta, that's going to be positive in the first quadrant there, right? My cosine, I'll do these in different colors. Cosine inverse of theta is positive here. And then I'll go green. Tangent inverse of theta. These are all positive, right? I'll go light blue since I haven't used that. That's all positive. Now, how about negative and negative? So for my sine, this is where sine inverse of theta is negative, and tangent is also negative down there as well. And then for my cosine, which I did orange, cosine inverse is in my second quadrant. And the last thing I'm going to jot down with this is going to be negative pi over 2, 0, pi over 2 are values that we're really using on these problems. All right, we're not going to be using this third quadrant over here. So feel free to jot that down. I think that one really illustrates it well, puts it all together for us. Okay, all righty. Let's keep rolling here. A couple more examples. So evaluate using a calculator to 3 decimal places. These are functions, and we'll have only one output for each input. So your calculator builds in there, it knows where it is defined, okay? So if we use our calculator here, inverse sine of negative 0.5, that'd be negative, let me use a darker color here, I'll go blue now. If I plug this in my calculator, negative 0.52 radians. Lovely, lovely. Or negative 30 degrees. Okay. All righty. Now the next one, 2/3. If I plug that in, I'm going to end up getting, I have my notes off to the side here. It'd be 0.841. Cool. Awesome sauce. And then for the next one, for negative 2/3, all right, that's going to end up being in the second quadrant where cosine is going to be negative within the 0 to pi restrictions. I'm going to have 2.30 radians here for this one. And then for the last one, I'm going to have, if I plug that in, that's going to be my fourth quadrant, right? A negative angle of rotation. I'm going to be negative 0.611 radians. And one thing I want to point out here, I think it's an appropriate time to do so. If I'm thinking about my unit circle, I'm always thinking about 0, pi over 2, pi, so on and so forth. Well, what is the equivalent of pi over 2? So I would have 0, then I'd have 1.57 would be about my pi over 2, 3.14. Okay, so you can start to think about what your decimal equivalents, and this would be negative 1.57 when we're talking about these, and negative pi over 2 rotation, right? So you can think about what your decimal equivalent is of your radians, and that will make a little more sense. Like you can clearly see that this one here is between 3.14 and 1.57. It's in the second quadrant, as I had said, right? This is clearly in the fourth quadrant here, because we went negative. We didn't go past the negative 1.57. It landed in that fourth quadrant there. Awesome. Last thing here, and then we're going to call it a day, if I'm not mistaken. Evaluate tangent of inverse sine of 1/2. Now we have 2 different functions that we're dealing with. So once again, we're going to use that where it's like onion, like in layers, and we're going to work from the inside out. So first off, inverse sine of 1/2. What is that? Meaning for what angle theta would we get 1/2? Well, special right triangles or unit circle, your method, your choice. I got 1, 2, and root 3. I know that that is a 30, 60, 90 triangle. This is a terrible, terrible root 3. There we go. It's a little better. That is a pi over 6 reference. So now I'm just evaluating tangent of pi over 6. Well, what's the tangent of pi over 6? I've already got the triangle there. I really didn't even actually care about the angle because I already have the triangle there, and that will tie into the next lesson. So tangent of pi over 6, opposite over adjacent, that's going to be 1 over root 3. And if I rationalize that, I'm going to get root 3 over 3 as my final answer for that one. Let's try uno más. Inverse cosine of sine of 5 pi over 4. Okay. So if I draw that up to figure out what sine of 5 pi over 4 is, that would put me over here, right? And 5, no, wait, I got to go further. Oh my goodness. We're past. Whoop. There we go. That was close. So this is a 45, 45, 90, 1, 1, and then root 2. 2 negative 1s and root 2. Okay. So that's what that is, right? but then I want to know what's cosine inverse of that. So my sine is going to be opposite over hypotenuse. So sine, let me actually finish this out before I go cosine or inverse cosine of that. This is going to be negative 1 over root 2, which is negative root 2 over 2 when I rationalize. Okay, that's the inside. So now I want to know what's cosine or inverse cosine of negative root 2 over 2. Actually, I think that was the first example that we did. So cosine is going to be negative in the second quadrant. So it's going to be my second quadrant, 45, right? Which we know is then 3 pi over 4. I can't just have 5 pi over 4. It ends up being 3 pi over 4 for that one because that's where the inverse cosine is defined. Woo! That was a bear of a lesson. Well done, children. Nice work. Actually, I don't know if you did well because I'm just here in my garage right now filming this video for the third time. Hope you enjoy it. Have a wonderful day. America, freedom, rock and roll, Costco, Riverdog Jenny on the gram. Don't forget to follow and have a wonderful, wonderful day and make good choices. See ya.